Chapter 9, Section 1. This is quadratic graphs and their properties. So remember, a quadratic function or a quadratic is something that can be written in this form: y equals ax squared plus bx plus c. The important thing to remember is this, basically this x squared, that it has an x squared term. If this bx and this c aren't there, that's fine, because it could be like 0x or plus 0. And so these are some examples of what it could look like. You could have just the x squared term. You could have just the x squared and a constant. Or you could have the x squared term, the x to the first and another constant. So it could look like any of that. But basically the standard form is when it's in this form, in that order. Okay, so yes, this is still considered standard form because even if there's no x value there. Okay? Okay, so what we're going to look at first is what's called the quadratic parent function. The quadratic parent function is basically the simplest form of a quadratic equation. Okay, and that is this. Now, f of x is just a function of, so it's the same thing as saying y equals x squared. So these two can be interchanged. Okay. And what that quadratic parent function looks like is a graph like this. So if you were to create just a little t-chart and plug in numbers, like -2, -1, 0, 1, and 2, and plug in -2 for x squared. -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. And if we graph these, we got -2 up, 1, 2, 3, 4 is right about there. -1, 1, -1, up 1, right about there. 0, 0 is right there. 1, 1 is right there. And 2, 4 is right there. And so that's where the shape of this graph, or where it comes from. And what we call that, it's kind of a U-shaped, but we call it a parabola. So the graph of a quadratic function is a parabola. Something about a parabola is that it's symmetrical. And so that symmetry is if you were to draw a line right down the middle here, it's the same. It's basically they're mirror images of each other. So that's one of an important characteristics of a parabola. Now, these parabolas have usually either a high or a low point, and that high or low point is called the vertex. And the vertex lands on that axis of symmetry. Remember, that axis of symmetry is this line that creates the mirror image. So, if a is greater than 0, that means the parabola opens upward, and that means that the vertex will be at the bottom, so it will have a minimum point. If a is less than 0, the parabola opens downward. So if this is a negative value, it'll open downward, and therefore the vertex will have a maximum point. So the real difference is, does it look like this, or does your parabola look like this? Either way, this point right here is going to be your vertex. So here all we're doing is identifying the coordinates of the vertex. So right here, here's your vertex. So those coordinates are 0 left and right, 3. 0, 3. Here, it's opening upwards. The vertex is right there, so that's 1, -1. Okay. Try this one. What is the coordinates of the vertex? Your vertex is right there. So it would be -2, -3. And then they also want you to say, is it a minimum or is it a maximum? And since this one opens upwards, this is a minimum. Okay, now graphing these. Graphing these can be kind of tricky, but the best way to do that is just make a table with your x's and your y's. Now, what numbers go in that table? You'll kind of learn that as we go along, which ones to put in there. But for right now, I'll tell you this. When you don't have anything after the x squared, the axis of symmetry is going to be the y axis. And so therefore, just those kind of the kind of normal numbers that you've been used to, -2, -1, 0, 1, and 2 are your best bets. Okay, so if we plug those in, -2 squared is 4. 4 times 1/3 is going to give us 4/3. -1 squared is 1. 1/3 times 1 is 1/3. 0 squared is 0. 1/3 times 0 is 0. 1 squared is 1. 1/3 times 1 is 1/3. And 2 squared is 4. 1/3 times 4 is 4/3. Now we just have to plot these. So -2 over 2 up to 4/3 is right about there. -1 1/3 is right about there. 0 0 is right there. 1 1/3 is right about there. And 2 4/3 is right about there. Now a lot of times it's not a bad idea to even get a couple more. I'll go -3 3. -3 squared is 9. 9 times 1/3, that's 9/3 or 3. And the same is going to be true for 3. So we got -3 up 3. This kind of gives us a better idea of what the graph actually looks like. So now we have something that's a little bit more accurate, and you're just going to connect the dots the best you can. Extend them. Give each side an arrow. And that is our graph. Okay. One thing I missed on this, so domain and range. Now, domain and range, if you remember, the domain is the numbers that you can put into this function, this graph, this equation. What numbers could you put in for x? What are your possibilities? Are there any limits on what you could put for x? And the answer is no. So our domain is all real numbers. And our range is if we put in all real numbers. So if we put in numbers from -infinity up to +infinity, what could the y be? What could our outputs be? And the answer is anything where y is greater than or equal to 0. This graph is going to continue to go up. It is never going to turn around and go backwards. And so we are never going to have a negative y value. So our range is y greater than or equal to 0. Okay, and that's what your domain and range is. Now, for right now, our domain is going to be almost always all real numbers, and our range will be some y greater than or equal to 0 or maybe less than or equal to 0. It'll kind of depend on right now whether this curve goes up or whether it's flipped and goes down. A little bit later, that will change. Okay. Okay. So the coefficient of x squared term affects basically how wide the parabola is and the direction in which it opens. So that ax squared part right there affects if it's a wide parabola, if it's a narrow parabola, or again, here's the parent. So this is kind of like this is the normal, okay? And so also whether it's opened up or down. And so if you look at these, as this number gets bigger, as a gets bigger in terms of whole number, don't look at the negative, but when it's 4, this is 1, right? So when it got bigger to 4, you notice how it got narrower? And when it got smaller, it was in 1/4, it got wider. So the bigger that number gets, the narrower it gets. The smaller the number gets, the wider it gets. The negative makes it open up downward, and if it's positive, it opens up upward. And those are the things to keep in mind. So again, number greater than 1 gets narrower. Number less than 1 gets wider. Negative makes it open up downward. Positive makes it open up upward. Okay. So if we look at this, in order from widest to narrowest, put these in order. So again, what we're looking at, we're not looking at the negative sign yet. We're looking at widest to narrowest. So which one's bigger and smaller? So here's a 1, this is a 3, and this is 1/3. So what's going to be the widest? The fractional one. So f of x being negative 1/3 x squared, that's going to be the widest. Next up is your almost your parent function. It's sorry about that. Let's try this one more time. Negative x squared, and then the bigger number, which is 3x squared. So that's f of x equals 3x squared. And that's going to be the narrowest. Okay, so that y-axis is the axis of symmetry. For graphs that are in that form of ax squared plus c, so whether there's a c there or not, the y is your axis of symmetry. So the difference is what happens when we add that c? Well, can you tell which one's blue? Which is this the blue graph or is this the blue graph? And the answer is this the blue graph. So what does that plus 3 actually do to our graph? And the answer to that is that plus 3 shifted our graph up 3. So looking at this part, the 2 made it a little bit narrower. The fact that it's positive, it opens upward. The 3 shifts it up 3. Where here we don't have the 3, and that's the red one. So again, this plus 3 makes it shift upward. What do you think a minus 3 would do? The answer is shift it down. So how are those graphs related? Same graph, but the vertex here would be starting down here at negative 3. Okay, so that's the difference here. Same parabola, same curve, but this one, the vertex is at -3, where this, the vertex is at 0. Okay. And that is really the difference between these graphs. And you're going to get more comfortable with it as you deal with a little bit more and more of them. But it's important right now for this section to understand that the number with the x squared causes it to get wider or narrower and open up or down. The constant, the c part, shifts it either up or down. Okay?